This conference will now be recorded.
Okay, so before going forward, I'll just give a brief of myself and then we'll move forward. So I'm Rudra. So I'm working in so and so company. I cannot relieve it. Okay. So I'm completely into backend. So that means like from synthesis to the sign off, I have worked completely. Okay, so this is a brief about myself, and in this particular course, we will be discussing the complete backend flow. That is what all concepts required, like synthesis, STA, physical design, all that we will be discussing. Okay, so power related checks you might be able to get a support, but recently we will be focusing on this. And also basics of physical verification, because nowadays what is happening is like the physical design engineer, that is like you, will be working on the physical verification for a smaller part. So that's why it's a good practice like to knowing that particular concepts as well. Okay, don't go in depth of it. What is a major goal? We will be focusing on that. That will be like a supporting task. Okay, so now before going into all this particular depth of, let's say, like SoC, system on chip, or let's say silicon on chip, few will be saying their names. So there are like categories. We are into depth of VLSI. Okay, so there is a parallel field also, FPGA. So you know the difference, right? VLSI and FPGA, right? So we are in VLSI industry. So in this particular VLSI industry, we have a separate set of flow. That is what we are going to be following. Okay, so first, what is IC? That is full form. What is IC?
Integrated circuit.
Yeah, that is full form. So we want is like whenever say what is IC, we don't want full form. Okay, we want is like a definition criteria. Let's say don't give a Google explanation also. That is not required also in industry. Just say like a keyword. Let's say more number of transistors in a smaller area, such that I can be able to move that particular circuit everywhere. For a simple example is like a mobile phone. The next example goes to a tab. Next goes to laptops. So like that, based on the requirement, you need to have that particular ICs getting developed, right? So according to the number of transistors, we have different categories: SSI, MSI, LSI, and VLSI. So ULSI, GLSI. So the names are going to be changing, but in general, our particular industry is termed as VLSI only. Okay, there are more transistors also. We are just saying it's like VLSI. That is like nearly 1 lakh transistors in one particular circuitry, right? But nowadays it's not just 1 lakh transistors, it's beyond that. Okay, but generally we are saying it's like only VLSI terminology only. Okay, because every time we need to change means it's going to be having an hectic process and it's going to be a confusional methodology. So that's why we are using VLSI terminology only. So for this industry, for any kind of, if you want to know have any knowledge means, I say is like knowing analog and digital basics is enough. Okay, that also will be covered in this particular course duration. The starting 1 month you will be having is like a basic session where you will be covering analog, digital, basics of scripting like Unix and Tickle, and the next part also you will be hearing about is like basic key terminologies of our flow. This is what they will try to cover in the basic sessions. Okay, so if you don't have ideology also, you can join that particular basic session and you can get it covered up. Okay, no issues. Knowing it is better, because why we are saying it, the reason is because when you go to any product company, let's say like Qualcomm, Intel, Broadcom, there are some more companies, they will be focusing on this particular digital conversions. Even though you go as experience also, they will be asking you about this particular digital conversions. Develop a mux using AND gates. So like that, there will be different types of questions asked. Okay, so that's why we ask everyone to prepare that particular task also. Okay, analog digital is little bit required. And in the analog devices, why we prefer is like this manufacturing process to be required. Why manufacturing process? The reason is because if we know that particular manufacturing process, we might be able to predict near to the end of manufacturing what will be the damage, such that what precautions I need to take. Okay, so for example, let's say like my transistor size is going to be reduced a lot, correct? As my transistor sizing is getting reduced, my drain to source distance is getting what? Reduced. That means the channel width is reduced a lot, correct? So as it is reduced, is it easy to form a channel or difficult to form a channel? Smaller distance, right?
Easy
It
to
will
farm
become
sir.
with a small charge also. My CMOS gets activated, right? PMOS or NMOS, anything gets activated. Now, what is the purpose of gate? Will the gate able to control that type of circuitry? When you are so close to each other, you can be able to easily handshake. Then what will happen? Then the third person cannot control me, right? Simple as that. So I need a control circuit now. So for that particular reasons, we have went into a technology called as FinFET. Okay, nowadays CMOS is like long one. We have now is a concept called as FinFET. But in the theoretical standards, it's not yet completely developed. It is developed only in the standards of, let's say, industrial level. That's why it's not getting updated into our particular subjects also. And also we use is like totally outdated syllabuses. So we don't get many of the things. Okay, when you go to masters, you will be able to get to know that particular concepts. But as a BTech or let's say BE professionals, we don't be able to get that particular kind of scenarios. Okay, so nowadays we have is like FinFET. In that particular FinFET also we have is like multiple types of FinFET according to the controlling structure. Okay, so let me try to show you an example. That is like in our earlier cases, we used to have drain, source, and a gate terminal. Correct? This is what we used to have. Some body terminal also will be there. Now, what has happened is like as this particular, when we are saying transistor sizing, or in other terms, technology node, we are saying, right? 10 nm, 5 nm, 3 nm. If you see our processor structure also, whenever you buy a phone, it is saying like 6 nm processor. 5 nm processor. So it is going to be indicating about this particular distance. Okay, technology node. So nowadays, the industries is currently trying to work in 2nm. This is the latest technology node which we are going to be working right now. Okay. After 2nm, then you need to go for quantum supercomputers. Right, so nowadays it's like purely based on the electron movement, right? When we go further, it will be based on the proton movement. Okay, so that's why later that will still take a time, but let's say knowing about this particular structure is also next level when you go to industry, right? So don't stop your study, so keep on studying, learn about quantum also, such that you can be able to survive in industry for a long time. Okay, so and also there are different types of manufacturing structures also. We know one particular process, right? Let's say in engineering, we have studied one type of transistor structuring, or let's say chip development type of manufacturing process. So that also the nowadays the Intel, or let's say the Samsung, whoever the manufacturing units are there for us, okay, they are trying to re-alter it in such a way that this particular technology can be developed in an easier. Okay, the requirement, the area can be simplified, and also there are some more drawbacks that can be simplified. So that's what we are trying to change in this particular manufacturing process. That's a complete different structure. If in Gujarat we get that particular complete structure, right, we can be able to go there and observe that particular manufacturing process also. Otherwise, when you get into manager position or director position, and if you're well known, then there is a chance that you can go and see that particular manufacturing process also. Okay, prove yourself. Okay, till now whatever we have done, that's like only to the mark extent and going into one particular level. Now it's like we need to prove ourselves in such a way that we are unique, we are not same as others. Okay, industries wants to make them follow their flow only, but try to prove yourself unique. So that can be gained only by using during your learning time. Focus on this. If you have other works also, please try to allocate time for this. Then you can be able to get more knowledge. Okay, and you can be unique. So now coming back, so now what has happened, as this particular distance is reduced, the gate control has become a problem. So now I have to introduce in such a way that I need to control that particular device using gate only. So how can I control it now? By using a concept called as FinFET. That is like in other terms, yeah. So I will be introducing an gate around that particular channel. Okay, gate around FET. Okay, GFET. FinFET, the first concept, GFET. So gate will be constructed around that particular channel such that I can be able to control it. So this is what FinFET means. Okay, so this is like internal. In your BTech or so, I think so you might not know it, but when you go to industries, you will be knowing about this particular concept. Okay, and also one more thing, we don't work in transistor level. Okay, in when you are working in labs of IC design, you will be working with respect to help of multiple AND gates or gates, right? That is like we will be using as like a small chips, correct, a black box kind of symbol. So we will be also using that type of circuitry initially to perform our particular tasks. Okay, later on stages, that is like during or before providing it to the next team, we will be going in depth of that particular levels. Currently we will be going with a black box criteria. Okay, so in this particular black box, what all we have, we will not be able to get it. Okay, right. Yes, there is a separate DV course available. So this is like purely for backend. So that's a front end course. So I'll just go with like ASIC flow now, and you will be able to get to know where you can be able to fit. Okay. Hmm. So for those is like those who are not good in coding. Okay, I'll suggest backend. Okay, so because you no need to much work on coding, a small amount of coding is required, but not that much level. For those who are good in coding, front end is like a suggestible. Okay, pay scale will be different. Okay, and also the task, the work will be also different. Okay, right. And I think so most of you might not know this particular, but if I am considering this particular session, if I'm taking it, so I'll use this particular application called as OneNote. Okay, so this try to use as much as possible, because OneNote helps you in multiple cases, wherein this is like a notebook where you can create multiple sections, multiple notes. Okay, so headers and multiple notes, such that you can be able to easily filter it out for what purpose that particular note is getting used. Okay, right. So now let's say, let's take it with an example. Okay, yeah, I'll discuss about that particular difference in technology nodes also. So first we'll go with the flow, and in that particular flow we will get in depth of each and every concept, not complete but basic depth, and then we will discuss about all this. Okay, so now coming back into this particular ASIC flow, before going into that, I'll go with an example. If you want to buy a phone, what are the first step, or let's say what is the first requirement you need? Features, right? A kind of idea, specification. So in that particular specification, what are the major tasks you will try to observe? Memory, next, RAM, processor. If you are gaming, then you should look for the processor first. Okay. Next, do you want a bigger phone or a smaller phone? Bigger phone. Then you can go for a tab, right? So, okay, just kidding. So, if you, based on your gaming or let's say based on your video, for what purpose you're using, you require your screen requirement. But as I'm an old trend person, I require is like smaller phones. Okay, right. So, now whenever we are trying to develop any criteria, the first requirement is idea, idea or specifications. So when we are constructing any kind of chip, in this the major three criteria is PPA: power, performance, area. Okay, power, performance, and area. So these are the three major criteria whenever you are trying to develop any kind of chip. Okay, your first focus will be. So let's say if you are focusing on your gaming, then will you worry about your timing and power? Sorry, will you worry about your area of the phone or power requirement, battery backup? If you're a gamer, I think that I need is like a more battery. But is that practically possible? No. Right? So that means based on your exact requirement, you should be less comfortable with respect to the other features. So that means if your performance is playing a role, power and area will be less focused. So like that, based on the requirement, it will be having the feature changes. Yeah. Is someone trying to ask a question? If no questions, can you please mute? Hello. Okay. Okay. So now I got the idea. So how many of you know about basics of coding? Well, I don't need very much, just a basic. So let's say I want to write a program. What is the first step you will try to do? Structure, right? Let's say flow chart. Syntax. Syntax is in depth of that particular coding. Okay. So first is like I need is like okay. So idea or specifications. Next is like I need to divide it. Let's say I want that particular phone to be developed. So in that I'll look for what all exact features I need. That is like camera, how much megapixels, processor, how what which type of processor, manufacturing processor. So everything I need. And again into that particular memory, SSD memory or HDD memory, 512 GB, 256 GB, 128 GB. And again going into this particular what else we have, area 6.5 inch, 6.7 inch, and next battery, how much, 5000 100 5000 mAh or 4000 mAh, what is the battery backup, heating requirement, everything I should be able to check. So in one particular phone itself, I need is like different sections available. So now what I need to do is like based on that particular idea which I have, I need to structurize it. Okay, I need to picturize it and I need to divide now. right? So I'm going to saying it as a term called as architectural design. Okay, so the complete architecture of my SOC, okay, or let's say my IC, the complete design will be designed by this particular architectural design. The power requirement, the timing requirement, the area requirement of each and every block which we have discussed, right? For your battery, for your camera, how much area it should be having, that we will be having it over here. Okay, architectural design. So this will be done by a highly experienced person. Okay, so next. Now, after this particular architectural design, now I got to know what all blogs I have. So that means what all programs I have to write, I have got an idea. Where I should place it, I have an idea. Now the next step goes into the RTL designer. This is the person who is going to be converting that particular specifications, and for that particular block all the requirement will be provided by this architectural design. He will write a code for it. Okay, he is going to be the coder, behavioral level of coding. Okay, so either in Verilog, system Verilog, or HDL languages, anything which that particular requirement requires, he will be writing that particular code. Okay, this is what RTL designer is going to do. A complete coding, behavioral coding. He will be knowing in-depth knowledge of that particular block related specification. So that means if he is working on camera module, he will be working on only camera module. He will not go into other block. If he goes, what will happen? A half-minded person is very dangerous. So that will happen. My design will be collapsed. Okay. I should pay that particular failure related thing also. If I'm buying it, if that particular design fails, right? Whoever the customer is, he will claim that particular amount from that particular company itself. So that kind of high problems are also there. Now, I have written a code. Whether it is following that particular functionality or not, I should verify it. Test bench related, right? Some kind of UVM, that related structures, everything will be coming. So, functional verification. DV, design verification. Okay, so this particular person is initially going to be testing that particular requirement is followed properly or not. Okay, so only that particular check, like by using that particular test bench codes, or let's say now it's advanced. So writing test bench is like a hectic process. So that has been developed into different languages. Okay, UVM, and also there are different tools to support it. So by using that particular tools, they are going to be doing this particular functional verification. For front-end designer to survive, knowing these two tasks is required. Knowing only RTL is like only up to a certain level. Okay, when it wants to, or let's say you want to advance his career, knowing functional verification will also be required. Okay, then he can advance to the next level. So now I have functionally verified it. Now comes the next task. Is like I need to verify that particular syntax, right? That particular behavioral code I have. Whether that particular behavioral code can be converted to a gate level format or not, I need to confirm it. So I hope so everyone know about gate level, right? So this is like for basic, let's say y equal to a and b is the behavioral code. So this particular code can be converted into gate level representation, which is present in some of the files. That can be converted or not, I need to verify it. Okay, and also for that particular design, what is the power related specifications also I should provide. And also the timing, you're saying 2.4 gigahertz is the processor, right? That particular timing related frequency requirement I should be able to provide it. Okay, so like that we have multiple tasks after this particular functional verification. Now let's say one more task. In my design, I have, for example, is like 2 million of cells. When I'm saying cells, it's of gates. And gate, or let's say sequential circuits, combinational and sequential circuits. I have is like 2 million cells. Will I be able to test them everything in a faster methodology? My design is failing. Okay, let's say my design is failing. Now, how can I test it? Simple, you have studied it in engineering. Stuck at 0, stuck at 1, ATPG, JTAG, right? Some concepts you have studied. We haven't focused much, but there are some concepts like that. So we are going to be saying is like DFT in simple terms, designed for testability. So those related modules also I need to insert it. RTL I have developed it with respect to the functional requirement. If I want to test it, I need a separate module for that. For example, JTAG or ATPG, which has its own developing of test bench vectors, and it is going to be processing that particular data. Right? You are not going to be passing any data, which is going to be processing it automatically. So DFT also is a separate team. Okay, so this all will be running parallelly after functional verification. That is like a team called as DFT. This is a separate course again. Okay, DFT is separate, and a process called as linting for this particular syntax related checking. Okay, and next you will be having a team called as CDC, a team called as clock domain crossing, and for timing related requirements, a timing analysis team who will be developing all that particular frequency requirements, some terms called as delay requirements, all that they will try to develop, where we will observe few things. Okay, we will know all that particular concepts. This is required for us. And also knowing about basics of CDC is also required. Okay, and next, power related UPF, that is like unified power format, and few people they will be, or let's say few industries they will be calling it as CLPT, conformal low poverty. UPF is unified power format, or CLP, conformal low power. Okay, so all this will be running in parallel. Okay, so for this all tasks we have a separate course also available called as RTL integration. If you want, you can be able to join that also. DFT is a separate task. RTL designer all and functional verification, we have separate courses. Based on your requirement, you will be having that particular course. Now, till this, we will be calling it as front end. Now comes a little bit more thing is like in industries, few of the companies will be asking for RTL designer to having a knowledge about timing analysis also. Because as I said, right, RTL designer, as he is developing that code from one particular module to another module, what all data is passing, should I analyze it or not, that analysis everything he will know it. So that's why all that particular timing analysis requirement, if he knows this, he will develop that particular timing file also. Okay, there is no separate team required for that. RTL designer only will try to develop that particular team. Front end related, could you please ask with respect to the admin? Because this is completely related to the back end, as I said initially itself. Okay, so where I'll just discussing about basics of ASIC flow, and after that I'll get into the advance of this particular physical design. Okay, so now DFT. So after, or let's say till this particular stages, we will be stating it as front end structure. After this, our particular backend starts, where I need to first convert behavioral code. I cannot be able to develop it directly, right? So I need to convert that particular RTL code into a gate level representation. So for that, we will be starting with synthesis. Okay, so synthesis is like working as an intermediate stage between your RTL to your backend PD. Okay, so now there is a small statement change now. So I have written here DFT, and few people will also say synthesis will also happen after DFT. I'll tell you why. So what will happen is like first your RTL code will be converted to gate level netlist without any kind of design for testability related requirements. I'll just directly convert my functional to the gate level netlist. That is independent of my scan related requirements. Okay, so let's say in a flip flop, how many pins you have idea about? What all pins you have idea about? Let's say D flip flop. What are those? Clock, Q, Q bar. Right? So based on your requirement, you will be either having Q or Q bar pin. Now, this is the only pins we have now. So that means it's a purely functional flip flop. Okay, where I cannot test this. It's purely if I provide original real data, then only that particular flip flop is going to be processing. Now we have one more category, or let's say there are multiple categories in it, but I am saying only two or three categories. Let's say Q, Q bar, D, clock, and next is like I'm going to be having a SI pin, and also I will going to be having scan enable pin, which means this particular flip flop is a scannable flip flop. That means based on the requirement of that particular design, or let's say working of that particular design, this flip flop can either work as a functional flip flop or a scannable flip flop. That means I can test this particular flip flop. SI means scan input. SE means scan enable. Okay, if its scan enable is 0, it's a functional flip flop. If it is 1, then it is a scannable flip flop. So all in this depth we'll discuss during our physical design course. And there is also one more pin which you might know, that is reset pin, to clear my data present in this particular flip flop. So reset related also we will be having. Okay, so now in this particular course, we need during the timing analysis, we will discuss about timing arc concept. That means how that particular data is propagated from input to output. So what all requirements are there internal to flip flop, that I should know. That also we will be discussing it. Okay, so the first step, as I said, your behavioral code is converted into this type of flip flop. In the second step, this particular functional flip flop, as I've already converted it, next I need to convert it into scannable flip flops, right? That means I need to pass some configurations. Okay, there is some kind of configuration which the DFT people will try to provide. Okay, I have to pass that particular configuration. convert that particular flip-flop to a scannable flip-flop, and pass this particular design to the physical design. Yeah. Testing. Let's say, as I said, right, I have this like 2 million standard cells. So testing everything will become a difficult if I start manufacturing process, right? So instead of testing 2 million cells one after the other, if I group them and provide it as one scan chain, that will become easy for testing, right? So that's what the this purpose of scannable flip-flops. Okay, so that in when I go to PD, I'll discuss that more. Okay, so now as there is a dependency of conversion, let's say a scannable configuration is required by this particular DFT team, till they provide it, should I stop my flow? Can I stop my flow? No, I shouldn't stop the flow. So what I'm going to do is I'll pass this particular functional flip-flop converted design to the physical design initially. Okay, so I have that particular main data. That means like if I convert it, if there is area change also, I'm not saying it area will change, I'm saying area might change. If there is a change also, there will be a small fractional change only, then I can be able to easily adjust it. Okay, so till that particular time, if I make him wait, what will happen, this RTL people, front end people will have a duration of, let's say, 1 year. The backend people, the complete backend flow will have only a duration of 6 months. To close that particular design, he will be having a shorter duration. That's why you are highly paid compared to the front end designers. Okay, not high, that means like not much variation, but there will be few variations available. Okay, now as this is a small duration available, so I need to utilize that particular time properly. So as soon as any RTL is released, so we will follow. If that particular scan configuration file is available, I'll pass this particular gate level netlist file to PD. If that particular file is not available, I'll pass the functional verification, sorry, functional converted design to that particular physical design. Okay, consuming time such that the area, the placing of cells, everything can be designed. Okay, now. So that's why. So this DFT is like providing the scan configuration file and incremental synthesis will be performed. Okay, and next comes our physical design, where you will be converting your till now which particular format of design we have. Everything is in like soft copy, right? File format. That I should be converting it into a hardware requirement. That is like layout structure. Okay, file to a layout. That is what we are going to do it in the physical design. And after that, we have is like sign off stage, where we are going to be verifying all that particular what all we have done so far. That is going to be verified in this particular sign off stage. Okay, and after that, I've verified all that particular task. That is like what all verifications we have. We will discuss that. Once that particular verification is done, I'll pass that particular GDS file, we say that GDS file to the foundry people. So my IC will be fabricated. So once this is fabricated, can I provide it to the customer directly? No, I need to again verify it post silicon validation. So after this post silicon validation, if it is successful, provide it to the customer. If it is not successful, provide a feedback to that particular team. Let's say mostly it will be provided to the backend, where they will be providing some functional modifications or some metal layer modifications or timing modifications. So that we will be calling it as ECOs. Okay. After that, it goes to the customer if it is successful. If not, it will be provided back. Okay. Clear? Everyone understood the basics of what is ASIC flow? Because when you go as a fresher, this is the first question asked most of the companies. Okay. So, can I move forward? In this particular ASIC flow, what we are going to be majorly focusing on is like, so what all we are going to be covering is like, first one, synthesis, and we are going to be using is like synopsis tools only. So cadence tools we are not going to use. Synthesis. Next is like timing, analysis, and physical verification, design, and physical verification. Okay, so all these particular four concepts we are going to be touching it in our particular course. Okay, I think so. Most of the questions I have answered. Let's say like different courses which we are going to be having in VLSA. I think I have answered that particular question. And the design difference between design verification and the physical verification. So design verification is like testing it logical. Physical verification means layout based verifications. Okay? So that difference between the technology nodes that we will discuss in few more minutes. Okay, and for synthesis, the tools which we are going to be using is design compiler, and for timing analysis, the tools which we are going to be using is majorly prime time, and there is a sub tool or let's say supporting tool which we should know for one of an input file. Supporting tool is star RC, which will help us to extract one of a required file for timing analysis. For physical design, the tool which we are going to be using is ICC2, and for physical verification, we are going to be using is ICC2 tool only, and we are going to be integrating a tool called as ICV. Okay, tool ICC2 by integrating ICV. So ICC2 means like IC compiler 2 and ICV represents IC validator. We don't have a separate flow for physical verification. By integrating ICV into the ICC2 tool, we are going to be performing the physical verification related checks. Okay, so these are the courses covered. And when it comes to the basics, as I discussed already, analog, digital, and when it comes to the coding, Linux, Tickle, and also the basic terminology before going into advanced, we will be having that particular terminologies covered. Okay, shall I go into our particular task now? Right. So, back. I'll just write it like back and forth. So, there are now in backend three different types of structures. First one is synthesis, second one is physical design, and the third one is sign off. So these three we are going to be covering. So first is like synthesis. So in this particular synthesis stage, As I said, what we are going to do, converting the RTL code or behavioral code to a gate level netlist. So I'll just mention as like a goal. That's what we are going to do, converting the RTL to gate level netlist. So in other terms, we can say is like converting technology independent. What the spelling? Independent file to technology dependent file. When we work on some task, I think I'll forget my spellings also. Okay, so this will be our goal. And also for this particular conversion, or let's say for this particular data to be modified, I need to provide some data to the tools, right? Such that I can be able to use that particular tool properly. So we have is like inputs. So I'll just write all what all inputs we have, and later on when we go to the advanced course, we'll go in depth of it. Okay, just writing like a brief. First requirement is like from my goal. What will be the first requirement? From my goal, what is the first requirement? RTL files. That's what I want to convert, right? So RTL files. Yeah, I'll tell what, with respect to what we are going to be saying it as technology dependent. Okay, so first we are saying is like technology independent. The reason because it's a behavioral code, right? In which it's a global language. You can use it everywhere. Okay, so the next is like I'm going to be converting it into a gate level netlist. That means I need the definitions of that particular gates, right? So if I define it as a module, then it's not actually a function definition, right? Gate level conversion. So when I'm saying it as a gate, that means it's already in a manufacturing process and it is verified properly. That means someone has structurized it and I want to use them into my design, right? So AND gate, if I provide module and so, and if I provide in this particular structure, is it like converting to a gate level netlist? No, right? I want to use some kind of header files, right? So that means someone has already developed it and verified it. Now, as this is an AND gate, this will be developed by analog designers. So they will be working with respect to the sub circuitry level, purely gate level. So they will be knowing about all the layout related structure, internal stick diagrams, right? So all this, these particular analog designers will be knowing it. So when I'm talking about basic gates, analog designers is going to do. Is it raining? Okay, analog designers is going to be working on purely analog related. That means they need to know about the stick diagram related structuring. So gates related. So similarly, there can be some kind of bigger circuitries. RAM, we are saying RAM frequently, right? So every time to develop RAM from a basic structure, it's a difficult, right? So I have is like microprocessors also, so that I can use it, right? You already manufactured it. Why should I manufacture from the base? I can use you, right? I can buy it from you and I can use it. So that this basic gates we will be calling it as standard cells. And next, the bigger circuits, I am going to be calling it as macros or IPs. This will be having SRAMs, DRAMs, all that kind of PLL, everything will be coming into this particular macros. SRAM, DRAM, PLL, and so on. There will be multiple. So when we are saying about standard cells, it's a basic gates, that is combinational and sequential circuits, that is simplex circuits. And when it comes to macros, it's a complex circuits. So this related information might be present in my RTL files, right? So this analog designers has developed, and for this IP teams has developed. I need to take it from them, I need to use it, right? So that means now from this particular they will be providing multiple files. For my synthesis, I require is like there are again different types of synthesis. That depth we will be discussing during our advanced concept. So in here, for me to perform basic synthesis, I require is timing requirement. So based on that particular technology, as my area is changing, okay, as the area of that particular circuitry is changing, the internal timing, power, everything will also be modified, right? So for each and every technology node, you should develop some files called as .lib, .lef, .gds. Like that, they will be having multiple files to be developed. Okay, this particular files is what you will be providing it into this particular synthesis or physical design. Okay, so that means I'm going to be converting the behavioral code to a .lib which is mapped to that particular technology only. Correct, a gate level from that particular technology only. So that naming also will be provided in such a way. For example, most namings will be like, if you are using TSMC, SAED 32 namings will be there. 32 represents the technology node. So for 28 nm or 32 nm, it will be the same. So that's why you will be having the same library used. Similarly, if you are saying SAED 14, then it represents 14 nm related libraries. Okay, so this what we say is like technology dependent netlist. How we are saying technology dependent netlist? As that particular behavioral code is getting mapped with respect to the gate level naming present in the .lib. That .lib is developed for each and every technology node. Clear? Did I answer your question? Can I erase this off? Just give me a second. It's raining started. Bangalore is found to rain now. Okay. So the next is I need to provide is library files. That is to be specific .lib. So .lib is liberty file we can say, or logical library file. So timing, power, area information will be present inside this. Okay. So next, if you have power intent information, so you will be providing the UPF file also. Power intent information. Let's say like to be brief, that is like multi voltage design or multi how can I say, it's like multi powers. Okay, multi voltage design or power switching related information will be present inside this UPF file. And what is the voltage level of that particular design, so that information will be present inside this UPF files. Okay, and next, timing constraints. So this content information, everything during the advanced course is what we will be discussing. I'm just writing in brief here. So we'll say is like .sdc, mcmm. So like this, we will be having different SDC, mcmm files. We will be providing. Okay, and next, if the DFT people already provide you a scan configuration file, you will be having scan.tcl file. This is not a compulsory file. Okay, scan.tcl file will be provided. So, and based on that type, I'm discussing about only one type of synthesis. So during advanced, we will discuss about another type of synthesis. Now I'm telling is like logical aware synthesis. Okay, so this all files will be required for your synthesis to be performed. So as I said, timing, power, area related information, as the synthesis is a logical synthesis which I am providing, area related information will not be provided. When you perform physical aware synthesis, area related information will be provided. That is the measure. So how that area information is provided, that varies. Okay. So we will be focusing on timing and power over here. Okay, internal to this particular design compiler itself, you will be having multiple internal compilers going to be performed for area optimization, for timing optimization, how that particular cell placement should be performed virtually. Okay, how that particular power is going to be used. So all that multiple internal compilers will be performed over here. So when you go as experienced, you need to know that information. For your fresher level, it's not required. Knowing what is enough. Okay. So next is like procedure. So these RTL files can be either Verilog, system Verilog, or HDL files. Okay. So again, here I'll write the terminologies. This is the flow of synthesis itself. Okay, it runs majorly in three different steps: analyze, elaborate, compile. So what each and every task is going to do, that we will see in the advanced level. Okay, this whenever anyone asks you what's the flow of synthesis, if you simply say analyze, elaborate, and compile, it's enough to. But internal, what is happening, that during the advanced we will discuss. And output files are which the files I need to pass it to the next stage. Physical design. It can be either physical design or timing analysis. Anything it can be there. Okay. Now, output files will be your gate level netlist. For user understanding, it will be named as .vg, but generally it's a .v file only. VG represents gate level netlist for user understanding. So next is like all this particular, or let's say few of this particular file namings will be with respect to the behavioral code name. Because in behavioral code we have is like one set of instantiations. So how many of you know what is instantiation? What is instantiation? All right. So let's say if I want to, as you said, if I have already defined full adder, let's say module full adder, and I have is like module something like that. So in this, I want to use this full adder multiple times. So instead of using that full code again and again, what we can do is like giving a nicknames. Full adder U1, full adder u2. So I'm going to be calling that particular full adder multiple times. So this is called as instantiations. Okay. So that naming changes might be there from my RTL code to this particular gate level netlist conversion because of internal of this particular compile where optimization is getting happened. We will be having that particular naming change. That means square braces might be converted to underscores, or some of the flip-flops might be removed, or some of the flip-flops might be merged. So like that, anything can happen internal to that particular compile. So this gate level netlist, now I have naming changes. So this UPF file also has to be extracted and passed. Okay. And next, we will extract the SDC file, which will not be passed to the next stage. Okay. You will extract it, but it will be not passed to the physical design. Why? We will discuss. Okay. But not now. Okay, it will not be let's say released to that particular physical design team. We will be releasing is like gate level netlist, UPF file, and scanf file. Major three files which you will release it to the physical design. SDC is not released. Why it is not released? That I'll keep it like a pause. Huh? Logs, timing related information will be provided in the SDC file. Whatever I provide, that will be provided here also. That means like with respect to the mapped structure, you will be able to find it. But still, I will not provide this particular file to the SDC. Sorry, physical design. So why? During the advanced, I'll keep it up. Okay, because if I'm keeping a pause here, which keeps on, that means you have to raise that particular questions during the advanced course. If anyone is taking, so why this particular SDC is not passed to the physical design? So why UPF is passed? So how that, what all changes will be there? That are the type of questions you need to ask during the advanced courses. Okay. So now .lib, should I extract it? Those are having the gate level informations only, right? That is already extracted by the other team. I'm just using it, so no need to re-extract it again. It's a waste of time, waste of memory. So as that is a global file, that I can use it for different stages. So once all these particular files are finalized, it will be stored into a directory called as central directory. If you have stored it, you cannot modify it. If you want to modify it, you need approvals. Okay, so that's why please make sure like whenever you have finalized your design, that is clean. So in this, you have multiple reports to check, like check design, logs, check timing, check scan chain, like that. This I'm writing commands only. I'm not writing the exact functionality over there. Okay, so this particular reports needs to be verified. So once it is verified, everything is clean, then only we will release it to the physical design. If it is not clean, then you have to clean it and then pass it. Is there any use of passing error data? Error data means the data which is not correct. If I pass it to you, what will happen? If I giving you a wrong statement, what will happen? You will consider that as true and you will keep on focusing on that, and when someone asks you, you will say that, right? At last your interview fails and you will start to scold me, right? So that's why each and every statement whatever we are saying, you need to verify it. Okay, even though I am experienced, I know what is correct, what is wrong, but you still need to verify it by using multiple websites. Don't go with one website. Even you can create a website. You can create a website, right? Based on your understanding. So that's why don't believe in one website. If any criteria, focus on multiple websites. Okay. Now, this is about the basic understanding of synthesis. So now, after this particular synthesis is done, we will go with respect to two different processes. Okay, that means all this particular reports, or let's say all this particular files, I'll pass it into two different processing units. One is like pre-layout STA, two called as physical design. Pre-layout STA, from that term, what can I say? Yeah, timing, I'm going to do it before my layout. That means with respect to the current net list, whether it is following properly the timing requirement or not, I'm going to be verifying. That means the libraries whichever I have used is proper or not. Okay, all that related timing frequency I have provided is following properly or not. Everything I'm going to be testing it in that pre-layout testing. Okay, that will be done parallelly. So at that same time, you will be passing it to physical design also. So the next task is physical design. So now, when I'm talking about physical design, now there are two types: flat level, hierarchical. Okay, flat level physical design and then hierarchical level physical design. So flat level represents one particular engineer is going to be completing that particular task from the RTL to sign off. I don't need multiple engineers to collaborate with me. I can complete it. Let's say like a simplex circuits, that is called as flat level. So when we are talking about hierarchical level, where I have is like multiple modules, for example your phone, okay, that requires is like multiple engineers. Why? Because there are so many parts in it, right? Or let's say complex circuits in it: camera module, processing module, memory. So like that we have different modules available. So according to the requirement, I need is multiple engineers. So I'll divide it and I will pass it to them. Okay. So first one we say is like input design or design planning. That means based on the level of working, in which level you're working, SOC level or block level, the terminology will change. If you're working in SOC level, it's called as design planning. That means what is going to happen is like in architectural design, what I said, one particular engineer is going to be converting that particular ideology into a flowchart structure and is going to be deciding the timing, power, area requirement of it. Right? So now I need is like in that particular layout where exactly that particular module is going to be sitting and what is the structure of it. Right? So we are saying is like always a square shape or a rectangular shape. This is what we are predicting it, right? But no, it's not always like that. You can also get L-shaped designs. You can get some puzzle shaped designs. So like that, you will be having different structures. When you have puzzle shaped structures, consider you're gone. You will be having more work because they will be little bit critical in few cases. Okay, when you get square or rectangle, there are different kind of difficulties you are going to be facing. Okay, the difficulties will change based on the design structure also. Okay, so in design planning stage, I'm going to be deciding the shape of it, Okay, and I will pass that particular information to the block level designer. Okay, block level designer will not have authority to modify it. Whatever SOC person is giving, I have to utilize that particular area effectively. Okay, so that's what the difference between SOC level and a block level designer. SOC is like chip level designer, block level designer is like individual divided blocks. Okay, so once I receive that particular outline structure, now our particular task is same as civil engineer only. We are not different from civil engineering. Civil engineer, he will work in sun. Physical design engineer will work in AC. Simple. The same task. Now the next structure is like, if any civil engineer, I'm saying like this is the specification you have to construct in this particular area. What he will try to do first? Plan it, right? So that means during that particular planning, he will try to focus on, sorry, yeah, area I have in that particular area, which are the bigger building blocks or let's say bigger rooms required, he will try to place them first. Correct? So we will be having a stage called as floor plan. In this, it's same as your civil engineering. That means we were going to be deciding what all bigger blocks are there that I'm going to be placing it first. Okay, and also I'll perform power plan also. That means power distribution also will be done. Okay, so in floor plan stage, what I'm going to do? Bigger blocks, that is your macros, IPs, everything I'm going to be placing it first. After that, I'm going to do the power plan. After that, I'm going for a stage called as placement. Okay, so I'll go in depth of that. First, I'll write down the flow. So after this particular placement stage, where your standard cells are going to be placed. Okay, so after this particular placement stage, we have is CTS, that is clock tree synthesis, and next will be your routing. Okay, clear so far? Right. So I'll go one by one. So let's say I'm working in block level or let's say chip top level. Let's say first one is import design stage. That means I need to load all the inputs which is provided by the synthesis and verify them. Okay, whether they are properly converted or not. Okay, whether the timing is how that particular timing is present in this particular physical design, whether I can accept that particular netlist or not. Everything needs to be verified it before going into this particular layout structure. Okay, so I need is inputs. Inputs required will be what all you have extracted from your synthesis stage. Those particular inputs should be provided, along with that some more extra inputs. Now that is like gate level netlist, UPF file, SDC file. SDC is synopsis design constraints. UPF represents unified power format. Okay, so SDC, these three files we have extracted, right? One more file we have extracted is CANDEF. But this SDC file is not from your synthesis stage. This is from your central directory. So, and some more files are required here is, as I'm working in layout representation, I need the technology related information. So when I'm saying technology related information, so I need is metal layer related information. That means routing, where my wire can route, how it can route. Okay, all that particular information is required. So that is called as technology file. And for each and every technology metal layer, okay, metal layer, there will be a parasitical change also, RLC, right? Parasitics are RLC. So that related information also to be provided. Big. Okay, so I'll just complete this input, then we'll take a break. Okay. So parasitics file, and next, what else did we provide the definitions of that particular gates or macros? In gate level netlist, we have it present, right? But we need that particular definitions also. When we are saying about definitions, what all type of definitions is required? Earlier I have provided is timing, right? Now I need is the area requirement of that particular, the shape of that particular, right? So I need is two type of files. So I'll just merge it into one file called as NDM, new data model. That is the latest version. In the latest versions, it will support new data model, which will be having logical library. That is your .lib, and physical library. That is your .lib. Okay, logical library and physical library. So these are the inputs required for your physical design. If we have missed anything during the flow, we will have that particular added. So let's say like stage to stage specification file. Based on the stage, there will be having some specifications required. Those related specifications we need to add them. Okay, so this will be the inputs required. And next we will be having a like checks. So that we will discuss after a break. Okay, all right.
What is the
So we'll
NDM
take a
full
break
form?
of 15 minutes. Sorry, someone is asking a question.
ND, NDM full form?
New data model.
New data model. And any one file is missing. Can we able to do design in import design
Based on
files?
the stage, based on the stage, if any file is missing, that particular stage will be stopped. So
Okay.
during the labs, right, we will ask you to perform this particular assignment also. That is like purposefully, we will try to miss that particular file, and at which stage it stopped and what all error you will observe, that you have to keep a note of it. That will be the lab practice. Okay, that also we'll discuss. So no issues. That is like during the advanced now. Okay, so we'll take a break of 15 minutes, and then we'll be back. So back at 11:10.
Sir, any errors are occurring? Can I find it where the error is coming?
Yes, log files. You have log files. So in that particular log files, what is that particular error? And also we can be able to see to that also in detail.
Okay, sir.
Any other questions?
In parasitic files, what it contains?
RLC information of metal layers.
Uh,
Okay, clear?
Sir,
Okay, yeah.
sir, when we are doing floor planning, at that time we are doing power planning as well. So, at that time, if we are doing power planning, then what is the need of UPF file?
UPF file is your power intent information will be present. As I said, right? Multi-voltage design, or let's say power switchable domains, those related information present will be present. For that, the equivalent specification information has to be created. So that when we discuss about floor planning, we'll discuss about that.
Okay, sir.
Okay.
Sir, could you please tell the career opportunities regarding VLSI for old students like 2018 passed outs?
So that can we discuss it in the end of the sessions?
Okay, sir.
Sure. I'll give you all the criterias and everything, okay? But few of the admin related questions, there will be a different person to be attending you. But most of the questions I'll try to answer. Okay, so I'll meet at 11:10 then. Okay, if you have questions, keep it posted in the chat, such that we will not miss that particular question. Okay. Hello everyone. Oops, I'm audible. Everyone is back. Online students, shall we start?
Yeah, you can go.
Okay. Thank you. So, okay. So now for all this particular inputs which we have discussed, right? So whenever you are starting any process, when you invoke any tool, you will first step is like creating a log file. Okay, log file is whatever we are going to be processing in that particular tool, that particular data will be stored into a file, because our particular screens will be running fast and fast. We might not be able to capture everything, right? There might be some errors, there might be some warnings, there might be some informational messages. We might need to study that particular flow. That all that particular data will be stored into that particular log file. So if we have any issue, the first information is like go through the log file. Observe each and every error, warning, informational messages also. Because some informational messages need to be focused. Okay. Now, errors and warnings with an high priority, informations with less priority. Only for your understanding. Okay, you don't need to report it or anything. Just for your information, knowing it is better, such that we will be able to get to know what is happening in that particular stages. So once I read, or let's say if I all this particular information or files will be provided through some commands and stored it into a file called as TCL file, tool command language file. Okay, through that particular tool command, I'll source it directly. Okay, all the information is saved. I'll just source it, and I will observe the log file only. Okay, once this particular file is completed, I'll start observing the log file and reports. If there are any abnormalities, let's say if you're facing any errors or warnings, you need to observe it and come to a solution by yourself. As much as possible, come to a solution by yourself. As it's an industry, less people will support you. To be frank, as it's an industry, it's a very competitive world. I might take your data, but I will not help you. Okay, I will take your scripts, I will take all your information, and I will project this as if I have done it, but I will not help you. That is secondary. That is the main thing happening in our most of the industries. Okay, so that's why come to a solution as much as possible, and don't believe anyone in the industry. Okay, outside it's different, but in industry, don't believe anyone. So the next is like reports. So for each and every information which you have loaded, you need to verify it either through log file or through certain set of commands. So what are those commands and how that particular reports are getting saved? Everything we will be observing it in the lab perspective and during the advanced classes. Okay, so what we will do is in advanced classes is like we will purposely not provide some of the files. Okay, till which particular stage it will work, that everything you need to know. Okay, we will give you some kind of assignments, we will give you some kind of practice, and we will give you some kind of excel sheets where you need to fill it. If you do it, you will be getting filtered fast. If you don't do it, you will be facing the difficulties, because this is what actually happens in industries also, because we might forget the data, right? Slowly when we go, whatever we have studied, we will forget it. If you have documented it, you can be able to refer it later also. So that's why we ask for that particular documentation, that only you will do it. Okay, please don't take the help of others. Okay, and also this particular scripting, whatever we are saying, right? TCL. So that we will ask you to do it itself. That means like by opening the tool, we will try to ask you for the searching of the command, okay, and also how that particular command syntax is going to be working. Everything you are going to do it manually. Okay, that's how you will be able to learn how to use the tool, how to get any command, and how to use it. Okay, so that's how we will try to focus. Just give me a second. There's a question. Checking the reports, getting the reports, and checking the reports. Okay, and also you need to provide the equivalent fixes if you are facing any errors. So for all that, what you should do, that all we will try to focus in the labs perspective. And in the advanced, let's say like theoretical classes and practical sessions, they will be divided. In theoretical classes, it will be happening only on Saturday and Sunday. And in the remaining weekdays or weekends, second half, you will be having that particular lab sessions going, where you will be having certain tasks to be done, so which you have to do it. Okay. Now, and the next criteria is floor plan. Okay, so in import design, we will just load all the inputs, design all that particular is loaded properly or not. That's what we are going to be verifying it. Okay, and next is floor plan. In this particular floor plan, we'll just go directly with respect to the goal. Okay, what is the goal of floor plan? Creating the your shape of your design and placing that particular
components.
bigger circuits, macros, correct. Okay, macros are IPs, such that your area is effectively utilized. Because I have some more small circuits available, so that also needs to be placed. If that particular macros is not analyzed and placed improperly, the area for that particular standard cell placement will not be enough. So we might need to reiterate this particular floor plan multiple times to get that particular effective floor plan. Okay, so your goal is to place the macros properly or effectively. Okay, indirectly it's like minimal utilization has to be performed. Okay, so now for this the requirements is what all requirements I need to perform the floor plan. Shape of the design, rectangular or rectilinear. Next is like size. Okay, that is like shape and size of the next is like, so from my design I will be having interfaces, right? That means like from my design it will be going outside, or from outside of the design it will be coming to internal. The signals can be transferred, right? So where that particular interfaces has to be placed, that information is also required. So a separate file called as PDF top design format or .io, that is like inout file, input output information file, which will be having the location information of that particular ports. In any of the format, it can be able to provide you either a tickle file or a PDF file or a PPT file or a pictorial representation. Anything they can be able to provide you that particular information. Okay, so Now, once I have that particular port information, the next is I have all the requirements. The next I'll start with respect to the placing of the macros. So this will be the requirements. That means this information is required for you before starting your floor plan stage. Once this particular information is provided, the next you will be starting with respect to the procedure. That is starting. That is like once that particular area, all this particular requirements is set, you will start with respect to the placing of macros. So for placing of this particular macros, we have certain set of guidelines. So what are those guidelines and what we should follow, what not to follow, everything we will be discussing during our advanced sessions. Okay. And also we will be having some concept called as pre-placements. The cells to be inserted before going into the next stages. So what all cells should be inserted, what are different types of pre-placed cells are there, that also we will discuss it later, advanced classes. And also placement attractions. So in this particular placement attractions, we have is like blockages, keep out margins, okay, routing blockages, all that. So what are different types of there and what is its purposes, way to use them, how to use them, everything we will be observing it practically and also in the advanced. Everything you have to do it. Okay. And also you have one more criteria is like types of floor plan. So what all problems you will be facing if a wrong macro placement is done, that everything also we will be having that disclosure. I'm not writing in a proper order, that will be interchanged. Okay, and there are multiple terminologies supporting to this particular floor plan. We are just saying one term called as design, right? Design structure. That particular there are different terms like use paint. We have multiple sub terminologies inside this particular floor plan. So few terminologies like core area, or let's say core boundary. This is internal to this particular core boundary. You will be having your macros and standard cells placed. Okay. The external boundary is called as die boundary or chip boundary. Beyond this, there will be no any extensions. Okay, and internal to this, you will be having is IO clearance area, where you will be placing your IO ports. Okay, every port has to be placed in this particular IO clearance area, where it has to be placed everything that is present inside your TDF. Okay, so this is about your basic terminologies, and internal to this particular core area, again there are some more terminologies. So what are those terminologies? How those are getting created? How this core height is getting created? Everything we will be discussing it during the advanced sessions. Okay. So for calculating this core area, what is the formula? Okay. So everything will be present inside that particular advanced. So I will write down some terminologies. And so on. There will be multiple. Okay, so now once this particular floor plan is done, you will be again performing some more sanity checks. That is like after each and every stage, it is a compulsory task that to verify that particular stage, whichever you have performed is proper or not. So that means sanity checks is compulsory. So in this, you have created your design, right? Whether while creating this particular shape, is there any irregularities formed? Because when I'm creating an outline, it might disturb some other features, whether it has disturbed or not. Okay, that all needs to be verified during this particular floor plan stage. During the macro placement, whether again, as I'm doing it manually, the macro placement is done manually only. If you have 400 macros also, you're going to do it manually in some industries. Okay, each and every bit of information has to be analyzed and you have to do it. 400 macros also you have to do it manual placement in some of the industries, and in some industries it has been automated. Okay, but preference is manual placement. Okay, so that's why in some of the companies you will be seeing is like floor plan is done completely by a separate engineer, so that database will be passed to the second engineer. Okay, from PNR flow we'll say, let's say like floor plan checks. In floor plan checks, we will be considering is like the internal of that particular design related, macro placement related, pre-placement cells related, all that we will be able to perform it. Okay. And the next is like timing related checks also. Just like to make assurance whether that particular timing is properly followed or not, whether any disturbances is there or not. All that you will need to cross check it again, timing checks, and also there will be multiple. As I said, I'm giving hints here. So the key terminology here is like you need to know is what all you're doing in theory, we are explaining in theory, that you need to do it in practical, and you need to verify it. Okay, if anyone is trying to miss you that particular information, it's your duty to ask it and do it. Mostly will not miss it, but if we have missed it, you have to ask it. You have all the rights. You can stop our flow, you can ask any question, and you can make a smooth flow. Okay, you have the flexibility over here. Any question, any number of times, we are ready to answer. Okay, the only thing is you have to ask. Okay, right. So now the next step is power plant. In power plant stage, the goal is to the goal is to power. Sorry. Okay, so I'll modify it. Distribution. The main thing is like power distribution, creating a power distribution network such that each and every cell will get enough power. Now, what is IR drop? What is EM violation? So how can we able to fix those violations? Everything we are going to be discussing in this particular power network. So for this particular actual analysis of power planning, we need the separate tool called as Red Hawk. Okay, that we don't discuss much it over here, because as I said, we are going to be focusing on physical design, timing and area related measure. So power related, that will be a separate team is going to be helping you out. So in this, we will be discussing about terminologies and flows, how that particular fixes can be done. All that we are going to be discussing it over here. Sorry? Okay, so that is like rings, straps or stripes, rails, bumps, trunks. It is based on the type of manufacturing of the design. We will be having a difference in the power network distribution also. That is like wire bound design and flip chip designs. So what are those differences in the manufacturing between wire bound design and a flip chip design? That also we will be discussing it during the advanced sessions. Okay, so now during this particular, there was a question actually during when we went to a break. That is like, what is the purpose of UPF file in this particular power plant stage? Similar to that, there was a question. So now, as I'm going to be creating a power network distribution system, that means based on the voltage requirement of that particular design, I need to create that particular power networks. Correct? If they are working at different voltages, then what should I do? Let's say a partial amount of this particular hall which we are sitting is working at 1.1 volt. I'll use paint better. Let's say, for example, this is your design structure, and there are now two different types of information present over here. Let's say in this there are some modules, module A, B, C is working at ABC is working at 1.1 volt, and D, E, F, G is working at zero point 0.9 volt. Okay, so I have this particular information. This information is provided in which file? UPF file. Okay, information provided through the UPF file. So as there is a difference in the voltage levels, can one particular power line be responsible to convert the voltage, or do I need separate power lines? Sorry, can I convert a power line from 1.1 volt to zero point 0.9 volt, or I need 1.1 volt line separately and zero point 0.9 volt separately? If I want a conversion, then what should I need it over there? A transformer, right? So again, I need supporting features for it. If transformer fails, again that particular 1.1 volt will be passed. That's a wastage of current. Instead of that, can I pass two different power lines? Only when there is required, I will pass it, because it's not only one line I'm going to be passing, right? I'm going to be passing multiple power lines such that my power is going to be equally distributed. Correct na? Understanding my point? So we need is separate power lines. Okay, no conversions. Okay, it is separate power lines has to be passed. Same like our particular power network distribution also. We are using separate power lines only, right? Why can't we use transformers and convert it internal to our homes itself? Right? For fridge, we are using is like high tension wires. But when we are using for fans or when you are using for tube lights, you are using is like less tension wires, because the internal support is also getting changed. According to that, the wire tension requirement is also changed. So that's why it's always preferable is like use different power lines. So that's why, as I need power, different power lines, I need a separate voltage area for that, such that those particular requirement cells will be placed in that particular area itself, and I can be able to distribute them properly. For example, industrial area, commercial, let's say house lines. We are placing it separately only, right? We are not merging it and placing. If you are placing industrial line and housing line in the same thing, what will happen? We are expecting a bill of 1,000, we will get a bill of 5,000 or 10,000, right? So that's what happens. So that's why you need to separate it and you need to place them. So that's why UPF file has to be placed, sorry, sourced first before going into the floor plan stage itself. Clear? I think so. I have answered your question. Okay. So now in this particular flow power plan again, we will check for basic checks. How our particular power structure has been formed. Okay, how we can be able to rectify it if it is not getting properly formed, or as how to create that particular missing nets. Everything we will be going to be performing it in the labs perspective. Okay, so again we have to perform this after this particular power plant. Compulsory task is log file observation. Okay, because in industry, when I say it in practical point of view, in industry this theoretical is like less usage. Whatever you are doing in labs, that's what you are majorly focusing on, right? When you studied in engineering and when you did in labs, it's a total different point of view. Same here also it goes. Theoretical knowledge is just for to know what is what. Practical knowledge is what you have to focus on. That is like after execution of each and every command, you have to go through the log file. Okay, that is your own task. We will guide you. You have to ask questions from. So what is exactly happening? We will just say it in theoretical, but you have to observe it in that opening the log file and you have to do it. That is also a task. Okay, like this we will be going in-depth task which will help you to crack an interview of 3 years experience. If you do what all we are trying to say, I can definitely assure you like we can make you go with a 3 years experience also. If you have a gap. Okay, that's your own risk. Okay, there are risk factors also. That is your own task. Okay, so now once this particular power planning is done, okay, once this particular power planning is done, what we are going with respect to the next stage? Placement stage. In this particular placement stage, we are going to be placing the standard cells. So while placing this particular standard cells also, we have certain observations or let's say tasks which the tool should do it. As I'm saying is like currently in our design is like we have is like 52K standard cells. Okay. When you go to industry, there will be complex circuits, let's say complex numbers, 2 million, 3 million, like that your count will be very hectic. Now each and every cell placement is difficult. If I have to observe the timing and I have to place that particular cell in that location, it's very difficult for a user to do it, or let's say any engineer to place that particular cells manually. So this task is done by the tool. Standard cells are automatically placed by the tool based on the timing requirement, or let's say based on what requirement you have provided to the tool. According to that, the tool is going to be placing it. Whether you want less congested design or less timing or less power, leakage, everything it based on it, the tool will try to optimize it and give you the result. So that is optimized. Less work for us. That's what we think. But that's the main word. Okay. So floor plan, once that particular floor plan is the major base, once it is fixed, your construction goes smooth. If it is failed, your construction will go smoothly, you will think, but it creates more problems later. Okay, so you might come back and redo and move forward. So that's the problem we are going to be facing it. That's the iterations we say. Okay, in placement, placing the standard cells. Where I need to place the standard cells? Inside which area? Inside the yeah, earlier we have discussed only three terminologies. Core area. Okay, inside the core area, by making sure design is less congested, better in timing, less leakage power, and so on. Okay, so like that, we will be having multiple checks to be done in this particular placement stage also. Because as everything the tool is going to automate it, again you might need to provide some rules for some standards. So for which particular criteria you are going to do it, that will have a change. Okay. Now the next is like we can say is like types of floor plan or procedure of floor plan. Sorry, types of placement or procedure of placement. That is like coarse or global placement, legalized placement, and detailed placement. Okay, so this will get varied. That's a like you might interchange them also based on your requirement. You might interchange how that particular usage you want to do it. Okay, and what all types of timing fixes, how congestion is going to be fixed, how power leakage power we are going to be fixing it, how can we control it, everything we can be able to discuss it during the advanced. Okay, and there will be after each and every stage sanity checks. So what all checks will there, we will be discussing it. Okay, next is like CTS stage, that is your clock tree synthesis. Now, for my sequential circuit to be working properly, what is the requirement? For my sequential circuits to be working properly, what is the major requirement? If it's wrong, also try to answer it out. That's where your confidence increases. Clocks should be passed properly. Okay, so there are synchronous clocks and asynchronous clocks. So that will change internally. Okay, so first priority is like before getting the data, I have to make sure like assurance of clock should reach at a proper interval. According to that, my data I need to adjust it. Okay, data and clock has to be synchronized way, right? Such that your data will be received and transferred properly. That's what we have to make sure. That means I have to make sure first criteria is my clocks is properly reaching to all the sequential circuits with a minimal variation. If I pass all the if I pass the clock at the same time to all the sequential circuits, what will happen? If it's synchronized, everything is synchronized, what will happen? Sorry, someone is trying to answer a question. Sorry, go ahead. Okay, there are multiple dolls. If every doll is keyed at the same time, what will happen? They start to run at same time. Because of that running, what will happen? Noise, right? We will hear noises. But now when we talk in this particular design perspective, as every sequential circuit is started to run at the same time, the power requirement of that particular device will be high, right? As every circuit is started to running at the same time, leakage will be, they are running, right? So leakage also will be having high. Next, like that we will be having multiple violation. So will the data be received properly? Will it be transferred
No,
properly?
no.
Multiple failures, right? So that's why a small variation has to be kept. This is actually an interview question. Okay, so why? What happens if the clock is reaching to all the sequential circuits? So like that, during the theoretical discussions itself, we will discuss about this type of interview questions also. Okay, so there will be let's say like when it comes to the actual interview questions, you will answer all the particular questions itself. We need to less focus at that time. Okay, theoretical discussion itself, we will have the interview perspective also, like how we are discussing it. Okay, so each and every concept we will try to go in depth. Okay, so the goal will be to build the clock network such that all the sequential circuits will receive the. Okay. So while receiving that particular clock, we have some terminologies to be followed. That is like uh, balanced skew. So what is skew? What are the different types of skew? Everything we will discuss it during our STA sessions. Okay. And minimal latency. What is latency? How to fix that particular latency? What are the different types of latencies? And how that particular latencies are provided? We will be able to discuss that. Okay, so this is what we are going to be following. So while building that particular clock network, how that particular clock network is developed, and what is the procedure of it, that all we will discuss it during the practical sessions. Okay, so next is routing. So this is like a quick concept. Okay, routing is, if we are reached routing, right? We are like, we can be saying like I am the king, or let's say queen. Okay, because we will be having less tensions. After this particular routing stage, it goes to the sign off stages where your headache will be moved to those particular persons. If you are working on PV, then you might have little bit headache. If you are not working on PD, then you can go and play table tennis, anything, caroms, anything you can be able to play. Practically, I'm saying this is the real time industry. So routing, the goal is to make sure all the networks are, or let's say all that particular virtual connections has been made to physical connections. And while making those particular physical connections, the physical violations should be less. Okay, to make sure all the virtual connections are physically done. Okay, by ensuring less physical violations like DRCs. Physical DRCs we can say LVS, antenna, and there are so and so. Timing related also they will be having a failure, so that we will try to perform. Okay, so once this particular routing is done, you will extract some files and you will pass it to the required teams. Okay, you will place it in the central directory. So from there, that particular respective team, they will try to receive that particular data. Once routing is done, files has been extracted, stored in the central directory, you will send a mail saying that this particular version has been released. So try to use that particular version and perform the task and come back. Okay, so they will now comes the next particular task is so routing, to be more specific, that is like virtual connections are there, right? So that imaginary connections will be made to the physical connection. It is like wires will be created. Okay, in which particular that particular wire has to be created, only that particular task will be performed. AC DC connections, no. Okay, so a chip we assume like it's only working in DC only, right? So you will be getting all that particular signals in DC perspective only. The fluctuations and everything will try to control it before coming into this particular chip. Because if we are trying to insert that particular AC related into our particular chip, again we need to introduce some more modules, which will again increase my area, right? So that's why that controlling factor will be outside your chip itself most. Okay, or let's say common to your chip. So after this, we'll get entered into sign off stage. So in this particular sign off, we will be discussing about STA and we will be discussing about physical verification. So in STA perspective, we have two categories. One is pre-layout STA, or let's say first, what is STA? We will discuss what are the concepts inside STA. What is clock? What is delay? What is the timing exceptions? Like that, we have multiple concepts. We'll discuss all that particular concepts, and also we will discuss about what is pre-layout STA, what is post-layout STA, and what are the fixes should be done. Everything we will be discussing it. So we will be running a separate flow for this particular STA related. Okay, how to do that particular timing fix? Yeah, static timing analysis. Okay, STA represents static timing analysis, and also we have a concept called as DTA, dynamic timing analysis. Knowing theoretically is enough because we cannot be able to do it, but that is because that is a real-time entity factor. Okay, okay, so now that ECO related phase we will be discussing. And after that, we have is physical verification, where where we will be discussing about DRCs, LVS, and manual routing, inserting of wires, deleting of wires, cutting the wires, manual way of rerouting into different metal layers. That all we will be discussing during this physical verification stages. Okay, so here we have is like two different projects. Okay, one is like 28 nm and the other one is 14 nm. Okay, so 28 nm will be going in the lab perspective. 14 nm is for your understanding, it will be with multiple errors and everything that you will do it by yourself. With the explanation provided for the 28 nm, you will develop the flow for the 14 nm. Okay, so that particular project you can use it for 28 nm also. Okay, only the difference will be change in the technology files, right? The inputs everything is same, the change will be the technology files related. So two different projects you will be trying to handle, and one project you will be doing from synthesis to sign off. Okay, and one project you will be performing it from your PNR flow. Okay, and weekly assignments, everything they will try to provide you the labs during the labs, and they will try to observe it. So those particular assessments will be taken, and they will be considered during the very much sign of cases. Okay, now if you guys have any questions, you can shoot. Theoretical, practical. You will be having only basic sessions. That is like you will be covering about analog, digital, TCL, Unix, Linux, and yeah, every day it will be having. Okay, that timings and everything they will try to post you. Okay. So I think a few of you will be now joining as a weekend because they will be working professionals also, right? So for them, it's based on the advanced level. I'll say Saturday, Sunday. That's why we have is like Saturday, Sunday theoretical, and the dedicated sessions for the weekend sessions will be on the weekend itself. If they want, they can do it on. They have access for the tools 24/7. It's not restricted. Okay, your tools will be accessed 24/7. You can access it. Okay, but make sure is like the only criteria is like if you're not using the tool, close it. Okay, how to do that invoking and everything. Once your labs is starting, they will try to teach you everything. Okay, please ensure like that will be done. Okay, so yeah, coming to this particular point which I want to discuss, I have discussed with offline students, but I want to discuss with online students. The thing is like the current task over here is like how we are going to be working in this particular institute is we are working in backend flow. That means we will be touching only the backend structure. The front end structure will not be touched. That is like knowing what and what in this ASIC flow. That's what we will be discussing, but touching in the course is not there. Okay, that as I said, synthesis, what extent you require of understanding for the PD flow, that we will discuss. A basic flow structure, performing the task, everything we will try to do it, but the major focus will be on the physical design. Okay, but the remaining like STA and synthesis will also be taught, but it will be of less. Okay, because our major focus is PD, because this is what required, but front end is not completely required for us to do it. So we will not touch the front end. And also, because I've been into the interview panel, I'll tell you face to face what is happening. So in most of the institutes, or let's say outside some of the institutes, what is happening is like they will be focusing on complete ASIC flow structure. Because of that particular ASIC flow structure, what you want to know, you will not get that complete idea. Okay, that we don't want it to happen. As we want to focus on PD, we are focusing it on PD itself. Okay, so compared to other institutes, we are restricted to that particular policy. We won't touch the front end prospect anyway. Okay, it's strictly prospected to the backend. So what will happen is like, as you are going as a fresher, and if you give me that particular resume saying that you are performed the complete ASIC flow, and if I ask any question internal to this physical design, you might face a difficulty to answer it. Okay, so you might be face is like, or let's say BC is like, you might not be as an interview panel. I will be saying is like you will not be fit for the job, because we want is like few concepts to be known. If that particular concepts is not known, then I'll simply say is like you are in a rejected case. I'll not say it face to face. We'll say is like HR will contact you. Okay, so that's why it's strictly prohibited. Okay, please, I suggest this like if you're focusing on one subject, focus only on that. Once your feel is like I'm good in that particular subject, then go into the other. Okay, that's your own task. Okay, but never forget your what's your main goal is. This is VLSI related, so FPGA will not be touched. FPGA is a separate course. Okay, this is purely VLSI. As I said, the tools, that is what we will be focusing on. So if you want FPGA, so FPGA is a separate course, you can join that also, but don't mix both. Focus only one. Okay, yeah, sorry, I forgot one particular question that was asked in the starting. That is like difference between 2 nm, 4 nm, 28 nm. The major difference is like criticality of the project we can see. So when you go to 2 nm, as the device circuitry everything is small, your area is less. When my area is less, as its functionality is more, the leakage power controlling will be high. Okay, the biggest factors which we are going to be observing here is like when we go into lower technology, more number of rules has to be verified. Let's say, as I said, double patterning, or let's say FinFET related, all that particular checks will be added extra. And also you will be having is like leakage power related control will be having extra. But the only advantage is like area of that particular circuit will be very 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 small compared to the higher technology nodes. So that will be the major differences. Okay, one is area related, second is leakage power related, and also as my area is getting reduced, I can introduce more complex circuits inside it. That means indirectly I'm going to be utilizing, if I use that particular area 28 nm for just say like opening of the door. When I go to lower technology node, I can use that particular same area for opening the door, closing the door, and also for scanning who is coming and who is going. For all that I can use it. That's what your device change will be there. Okay, features gets added in that particular area itself. Okay, right. So this is the major differences. Any other question you guys want to ask? Laptop is not required for basic. Advanced, yes. Sorry. For theoretical, you don't need it. For theoretical, if you have written notes, it's fine. And if I'm taking the sessions, right, I'll not share any kind of note material in the starting. Once the course duration is completed, I'll share that particular notes. Till that particular time, you have to write it down, you have to revise it, and you have to ask questions from that. Okay? Handwritten, I prefer of doing is like handwritten notes. Okay? Right. So,
In the starting, we are doing a basic course like analog and digital related things, right? In that one, is there any labs we are going to conduct?
no, for the analog
Only.
digital, it's like theoretical only, right? So for digital
Okay.
conversions and all, you are going to be using is like K maps and all. So no labs for that.
Okay, everything we have to write in written notes.
Yes. So they will
For
be
that, there will.
as how I'm teaching you, right? It's like how I've written this particular notes and everything. So the similar way that particular whoever is taking you, the trainer, will try to create a notes. So on his basis, he will try to share you that particular material also. And
Okay.
also, I think so from your batch, there were notes also for you provided, books provided of that particular courses as well. Okay. So labs will be started from your advanced courses. In basic courses, you will be having is like purely theoretical. If you write it down, it's like our old saying: study, write it. We will get it memorized a lot.
And the classes will be how many hours? Like in the
Uh,
basic course,
3 hours duration.
3 hours continuously. It will be 3 hours.
Yes, with breaks.
That okay. The timings.
That they will post you. Okay,
Okay,
before
from that
let's say
to
like every week, before Monday or let's say like Saturday, they will try to post you that particular timings and everything when the class session starts. Let's say timing to timing, and such that you can be able to plan it accordingly.
okay.
Sir, recorded classes are available because still now I am working in a company.
Yeah, recorded sessions will be available. So each and every session we are handling, it will be recorded. If you are not recording also, you can ask me directly, like start recording. Okay, every session will be recorded and stored in website, and the access will be shared. The recordings will be stored in a website. Okay, so that particular website link, they will try to share it with you through that particular mail. So you will be getting access like to the server. One is like VPN access, the second one is like login access to the Unix accounts, and the third one is like recorded sessions related access. So three different access you will be able to get it. Okay.
Sir, is there any difference between can I attend offline classes and online classes?
Offline classes and online classes is like if you don't use your phone in online sessions, then you can let's say like be interactive. Okay, because I cannot be able to observe you, or let's say like you what you are doing. So because most we can get easily deviated from the topic, because when you are online we can't focus much on this particular thing. But if you are online offline, what is the thing is like, and can be able to see face to face, whether you understood or not, I can be able to understand it. Whether you are sleepy or not, I can be able to understand it. Okay. So as this is demo, we went in that particular flow, but when it goes to theoretical, it will be a different slow phase, and according to your phase I can be able to adjust it. So I feel is like, according to my experience, I feel is like offline is little bit better compared to online. Okay. Any other questions? As I said earlier, so if you know about the coding languages like Verilog, System Verilog, or let's say if you're comfortable about the coding, you can go with front end. Let's say I am less comfortable with coding and I want to work majorly on the timing perspective, or let's say cell placement, how it is going to do it. Physical layout structuring, I suggest you is like backend. Both are better, so it's based on in which particular language you're comfortable, you can choose it. Because I'll prefer is like I know coding, but I prefer less coding. The reason is because if there is a small issue is also, it will be like little bit bigger task. So that's why I prefer is like less coding, and I'm more comfortable about this particular circuitry layout structuring timing related, so I prefer backend. It varies from person to person. Okay. Yeah. Someone asked me earlier that is like 2018 passed outs, or let's say how is it? So now there are two different ways of getting into industry. Okay. I'll be a little bit frank and I'll say it. First task is like, if though how experienced you are, okay, sorry, how much gap you have, you can be able to fill the experience, fake experience, and you can be able to join into the company. But when you're trying to do that, make sure is like, the first thing is like you are knowing a very good practical knowledge, and the second thing is like the one who is providing you will clear all your back. Okay, BGV, that should be cleared out by him. Okay, that is your, that there are risk for that. The second thing is like, join into a service based company. Okay, if there are openings in any kind of product based companies, you can join in that, there is no wrong in it. But preferably join into a service based company. I'll suggest you, first thing is like, join into a service based. When you join into a service based company, they will try to always consider a person who is having a minimum gap. Okay, 2018 or 2015, anything, they will try to fill that gap with their own experience. They will try to clear all that. They will project you, they will provide you all the support. Okay, to make sure is like your task is going smoothly. They will be providing because they are providing you that particular experience. You will be lessly paid for that particular experience, but yeah, you can gain knowledge. First thing, when you join any service based company, your knowledge will be increased because you will be working in different flows. Let's say our first client worked in AMD. Once that particular project is completed, you might move into another project which is of different company or in the same company also. If it is same company, the same flow. If it is a different company, you will gain that particular company experience. So like that, you might work in different flows. Okay, and also you will know about different companies work culture. Okay, how it is, how we can be able to work with people, all that you will be able to get it known with respect to a service based company. But when you join any product based company, you are restricted to that particular flow, and you're restricted to that particular team only. So that's the only difference. So that's why I suggest first step when you enter into industry, service based company. Okay, so with that gap also, this particular service based company will try to recruit you based on the requirement available. Okay, so currently institute is available in Bangalore only. So you might be able to come over here, or you can join online also. Okay, so coming into the timings, so mostly Saturday, Sunday, theoretical timings will be in the morning. Okay, afternoon will be a lab sessions. Very rarely, if I'm busy or let's say if the trainer gets any kind of critical project timings, so that particular sessions will be arranged accordingly. Okay, so as we want to keep in mind about the working professional also, so theoretical sessions will be handled only in the weekends. Okay, so for weekdays, 4 days lab sessions you will be having. So that will be again mostly 9:30 to 12:30, or let's say 10 to 1 timings. Okay, any questions? Everyone is
Hello.
clear? If no questions, we can close it. Yeah.
Sir. Sir, in case during these 6 months, if we are failed to cover that all the concepts, means whether we will increase the duration, sir.
Yes, but that will be based on the discussion with respect to the admin. I'm not sure of it, whether there will be any cost of it or not. And also, I think so there is a flexibility of rejoining that particular course if you want. Let's say if you're having some kind of issues faced or anything, you can be able to rejoin that particular course again.
So next doubt clarifying section. That means we have only 2 days only, no, the theory classes at Saturday and Sunday.
Yes.
Yeah, that means doubt clarification. For doubt clarification, there is a separate hours or during class itself, sir.
Okay, so how it will happen is like every session, okay, let's say if I'm handling the theory, the starting 15 minutes will be allocated, or let's say till your doubts get clarified, we will be having that particular doubt clarification itself. Okay, and after that only we will be having that particular theoretical section, or let's say next part is going to be started. Okay, you can ask any theoretical or practical sessions during that particular starting off itself. At the end also you can ask, there is no wrong in it. Okay, so if there are multiple doubts, everyone is facing any issue, then we can arrange one particular doubt clarification session for that particular stage basis. Okay, because with doubts I won't move forward. I have to clear
Okay,
that doubt,
okay,
then
sir.
only I'll move forward. Okay, right. Okay, so I hope so there are no further questions. Can I close it?
Yeah, sir.
Okay, thanks everyone. So if you feel any kind of questions, you know the institute numbers, right? You can call them and ask them anytime. Yeah, there is a separate two course for analog layout design. Yeah, you can leave if there are no questions. No restriction. Okay, for analog designs, we have is like a separate course. They you can be able to discuss with respect to that. For that. Okay, thanks everyone. Hope so we'll meet
Okay,
soon.
sir. Thank you.